Hello, welcome to Solved with Danny, and today we are going to be solving multi-step equations with variables on both sides of the equations, but also throwing in lots and lots of fractions. So all the things in one, okay? And hopefully after this lesson you hate math just a little less. So shout out, I stole this worksheet off of Google many moons ago from a free math worksheets website. So if you're ever looking for more practice problems, just Google it. You'll probably find some. Okay, and if you watched any of my other previous equations videos, you know I like to use the acronym DCVS. So this is trying to simplify that multi-step equation into something that's much more smaller and palatable. So D means, is there anything we can simplify by distributing? No, not in this one. But is there anything we can combine like terms? Well, I do have some terms with x's in it, but they are all fractions with different denominators. So this is a fun one where in this case, we need to find the least common denominator first. So we have 3, 2, and 4, and the least common denominator of all of those will be the least common multiple of the denominators. If you are like, what's that? So a number they all go into would be 12. So the LCD for this is going to be 12. So what we're going to do next is multiply each of these pieces of the equation by 12 over 1. Because as long as I'm doing it to everybody on both sides, life is good. We're just making it so we don't have to look at those disgusting fractions anymore. So I'm going to rewrite this. I'm going to zoom in a little bit. All right. And I know my Apple Pen, not in yet. So we get my little sausage link fingers. Okay. So we're going to multiply everybody by 12. And I like to physically write it. I'm going to make that text much smaller. Okay. So I'm going to do 12 over 1. If you're wondering why I'm looking down, it's because my iPad is down here. Okay. X over 3 plus 12 over 1 times 1/2 plus 12 over 1 times x over 4 equals 12 over 1 times 3/4. Oh boy. Let's move this sucker out of the way. All right. Plus 12 over 1 times x over 3. Wow. It's a lot, but it's okay. We're going to simplify now. So I like to do a little cross-canceling action here. So 3 dies away. This is a 4. Over here, 2 is gone. This is a 6. Over here, 4 is gone, and this is a 3. That's really like saying 12 divided by 3 is 4. 12 divided by 2 is 6. 12 divided by 4 is 3, okay? And samesies over here. 12 over 4 is 3. And 12 over 3 is 4. Ugh, so many pieces. Okay, I know, so gross. So 4 over 1 times x over 1 is 4x. 6 over 1 times 1 over 1 is just 6, so that's nice. 3 over 1 times x over 1 is 3x. So that left-hand side, so much better now, right? 3 over 1 times 3 over 1 is 9. And then 4 over 1 times x over 1 is 4x. Now this equation, this is significantly nicer to look at than the original, right? Okay, so we go back to our DCVS. Now we can combine some like terms. All right. And I'm going to drop my line down so don't forget about it. So we have 4x and 3x on that left-hand side. That is going to give us 7x. And then I'll bring down all my other pieces. Okay, now here we want to get all the variables to one side and all the constants, the stuff without the variables, to the other side, okay? Now, it technically does not matter which piece you move first, but I always like to move the piece where I'm not dealing with negatives. If I can avoid a negative, I'm going to, because then that just leaves less errors that we could potentially make later on, okay? So next, the V is variables on both on the same side. We got to get there. So I'm going to elect to move that plus 4x because that will make it so that I don't have a negative x that I'm working with. Now, you can't always avoid negatives, but if we can, we will. All right, so that cancels out. 7x minus 4x is 3x. And then we'll drop down the rest of our pieces. Okay, this is looking much nicer. Now we're down to a two-step equation. This looks more traditional. We're happy. So I like to, I'm going to extend that line down. And if you still like to circle the term with your variable, after you're down to just one piece with a variable, you can still totally do that. It makes it look a little nicer. So then it's like, oh, this is like a one-step equation because now what piece can I move? I'm going to subtract that 6 from each side. So we're left with 3x equals 3. One last step to get x alone. Divide by 3. We get x equals 1. And that, who knew, smiley face, we would get that pretty answer out of that disgusting problem. Well, okay, so nice. So let's do another one. Oops. Okay. Let's do this one. Okay. So let's write my little DCVS over here. Now this one we can distribute, which is very exciting. So this 2/5. And there's more than one way to start this. Technically, I didn't have to do this, but I'm going to simplify it because that's just how I roll. So we have 2/5 times x. That's 2/5 x, or you can even write it as 2x over 5. It's the same, all good. Minus 2/5 times 4. It's really like 4 is over 1. So, and you can even write it out if you're like, ooh, I don't know, I don't love it. You can write it out like that, or you can slap it in your Texas Instruments calculator. Either is fine, whatever works for you. Now, it's not getting distributed to the half because you can't distribute across an equal sign, okay? So it's just to those two pieces in that binomial. All right, so let's simplify this just a pinch more. I'm going to move this up because I have a feeling I am going to run out of room. Okay. So we have, I'm going to write it as 2x over 5 just to make it a little nicer when we get to the next step. 2/5 times 4 is 8/5 equals 1/2. Okay, so now there's no like terms I can combine, and I'm looking at those fractions and I'm like, blah, this is gross. Okay, so for me, I like to kill off all the denominators. There's another way to solve this, but I want to kill off the denominators here. All right, so we need to find our least common denominator. So the least common multiple of those denominators, which is 5 and 2, is going to give us 10. So that means I'm going to multiply every single piece of this equation by 10. So as long as I'm doing it to everybody, we're all good. All staying mathematically sound. Okay, sorry, I got the sniffles today. So 10 over 1 times 2x over 5 minus, so always bringing down those symbols, right? 10 over 1 times 8 over 5 equals 10 over 1 times 1 over 2. So that's what we're going to simplify. So 10 and 5 are going to cross cancel to 2 and 1. So same here, same here. Life is good. And then 10 and 2, 1 and 5. So scoochie that up just a little bit. We're left with 4x minus 16 equals 5. Oh, much nicer to look at. So the hardest part of these is going to be figuring out like, okay, what is my common denominator? If you use the least common denominator, it's good. But as long as you use a common denominator, it's all going to work out the same. All right, let's drop our line down, circle our term with a variable. Again, you don't have to do that, but it's how I like to roll, okay? So we are going to add 16 to each side. Excuse me. So you might be looking at it at this step and being like, did I do something wrong? No, sometimes you just get a fraction as an answer. That's all good. It's all good. So we are going to divide each side by 4. So there's 2 ways we can write this answer. You can leave it as 21 over fourths. It won't simplify anymore. So improper fractions are cool, but if that like just gets your goat, you can write it as 5 1/4. Personally, I'm an improper fractions chick, but to each their own. And usually when you're like, as you get into higher levels of math, like improper fractions, that's just what you're going to be working with. So not too shabby there. All right. Let's do one more. All right, because this one has some fraction pieces and some not fraction pieces. So that's really fun. Okay. DCVS. Do I have to distribute? Nope. Sweet. Can I combine like terms? Well, we got to take care of those fractions first. So again, there's always going to be more than one, not always, but a lot of times there's going to be more than one way to solve this. I'm just choosing the way to kill the denominators. Okay, that's what makes me happy. So now you're like, but the left side doesn't have a denominator. Well, technically this is all over 1. So what is the least common denominator of 1, 2, and 3? It is 6. All of those numbers go into 6. So just like before, we are going to multiply each piece by 6. Now notice that whole left-hand side I put over 1. So I'm going to treat that like a binomial, okay? So, and because I'm going to treat it like a binomial, I'm even going to put it in parentheses so that I don't forget to multiply a piece out, okay? So we are multiplying by each and every piece, which I guess I could have done 3x over 1 and then 2 over 1, but this is like slightly shorter, just slightly. If you're someone who's like, I like a shortcut, like me, here we are. Okay, so we are going to cross cancel. Now on the left, nothing is cross canceling there because both of those denominators are a 1. So here we are simply going to distribute, okay? So 6 times 3x is 18x. Bringing that subtraction sign down, and then 6 times 2 is 12. Okay, now the left-hand side, we got some cross-canceling going down. 6 over 2 is 3, so that 2 goes away, 6 becomes a 3. And then the other way, 6 over 3 is 2. Okay, so 3 times 1 is 3. Bring my subtraction sign down. 2 times x is 2x. Okay, a little bit nicer of a problem to look at, but we still have variables on both sides, right? So again, I like to do anything in my power to make it so that my x is not negative. Okay, I do not like dealing with negative x's. I will, but if we don't have to, why bother, right? So I'm personally going to add over this 2x first. So that's gone. So we get 20x. Oh, I want to do that in pink. I know there's some math teacher out there watching this like, oh my God, she uses way too many colors. Well, that's how I roll. This is my YouTube channel, not yours. Okay, so we've got 20x minus 12 equals 3. And now we're back to that pretty 2-step equation, like, insert angel voices, right? Okay, circle my variable, got my line down. We are going to add 12 over. Yay, we. 20x equals 15. Now again, fractional answer. It's going to be okay because we are going to divide each side by 20. And anytime I have a fraction that can simplify, I will. And this one happens to be not improper. So 15 over 20. There's two ways we can simplify this, with or without the calculadora. Okay. So option 1 is in your calculator. So in your calculator, what you can plug in to simplify this fraction without having to like do it by hand. Now this is a TI 84 plus CE, is my personal favorite calculator. Shout out Dana Morris for hooking me up with some Smart View on my laptop. I so appreciate you if he ever watches this video. So we are gonna put in a fraction, which if you hit the green alpha button, and then the one right next to it, check that out. We have a numerator and a denominator. So I can put in 15 over 20. And now, bada bing, it simplifies it to 3/4 for you. So don't work harder. Use your tools, okay? So let's get back to that problem. So we got 3/4 as our answer. And again, I'm going to leave this as a fraction. I'm not a decimal fan. Fractions, they are our friends. So I hope that helps. I will show you the rest of this worksheet because I didn't go over all the problems. But if you wanted to solve some others, pause really quick. And there's the full answer key if you wanted to try a couple more on your own. So have a great day, and hopefully you hate math just a little less. Bye, everybody.